Do you find great homogeneity between subjects in the way that they process memories?
Well, with the caveat that we're using a very blunt instrument, even though we have brain imaging. Um, at the level of brain imaging, on this particular test, we don't see much difference. There are other tests that we've used that we've gotten from other people who studied them much more than we did, that show that as people learn it, the area of their brain that they use shifts. So they start out treating it as an episodic learning task, and you see a lot of activity in the hippocampus. And then over time, and I would argue over days with nights of sleep in between, it becomes proceduralized. And you see that hippocampus becoming less active and the striate cortex becoming more active. And it turns out that if you have people who are sleep deprived, they will you'll often see a decrease in activity, just baseline activity in some portions of the brain. And if those are portions that are important for a particular task that they've learned, they'll now use a new part of their brain. And maybe the best way to think of this is when you're trying to do those anagram puzzles, where someone gives you, 5 letters and you have to figure out what word you can spell by rearranging the letters. There's basically 2 ways that people do it. They start saying, okay, there's 2 vowels. There's probably 2 syllables. It's probably a consonant, a vowel, consonant, vowel, consonant. Maybe the E is the second, and they'll start trying to find the word. And other people will just stare at the letters until they say, oh, apple. And you say, well, how did you know that? And they'll say, it just popped out. And if you look in the brain, you find that they're using very different brain regions because they're using different approaches to solve the same problem. Whether sleep regularizes that so that everybody does it the same way, whether sleep shifts it from one way of processing it to another, not enough people in the field yet to really have gotten to the answers to those questions. But those are good questions for us to be asking.
Yeah, I was going to ask about sleep deprivation next, and whether you had run experiments, maybe not with this particular number typing task of procedural memory, but what happens to performance and within the brain if the participant doesn't sleep in those 12 intervening hours after an evening learning, or 2 days of no sleep? What happens?
So it depends on the type of memory we're talking about. You remember I said, if you teach someone to type 41324 in the morning and they get maybe 60% faster over the course of training, and then you bring them back that evening, they'll be exactly where they were at the end of training. That's a procedural task, and that's typical of procedural memories. If instead in the morning I had taught them a couple of dozen word pairs, dog and lamp, memory and tape, different word pairs. And so that if I gave them the first one, they could remember the second one after we've gone through the list a dozen times and they practiced it. If they learn 24 words that way, by the evening, they'll only remember 18, maybe 16. So with episodic memory, there's a lot of forgetting across waking. So why is that important? So if I train someone on the finger tapping task in the evening and keep them up all night and test them the next morning, they'll be just where they were the evening before. So they won't have forgotten it, but they won't have gotten better. If I then let them sleep the next night, it's too late. They won't get any better the second night. You only get, in terms of sleep, you only get 1 night to do this sleep-dependent memory processing. If I had taught them words and they learned at the end of training 22 out of the 24, I bring them back that evening, they only remember 16 or 18. If I train them in the evening, they'll still remember 22 or 24. the next morning. So with episodic memory, it strengthens it in the sense that it prevents it from being forgotten. And in fact, they won't forget over the next 12 hours of wake either. It's not just that they were asleep. It was changing the memory to be resistant to that type of forgetting. And if we keep them up all night, you can guess the answer. They'll be down to 16 or 18 the next morning.
And do you at all take into account the amount of time that people are sleeping or the quality of their sleep for these studies? Or is that you do? Okay.
Yes. So the very first task that I worked on was what we call a visual discrimination task. We would have a screen that was full of horizontal bars all over the place. And then in the lower left quadrant, there'd be 3 diagonal bars, and they'd either be next to each other or above each other. And we would flash the screen for a very short period of time, milliseconds, and then ask them, were they above each other or were they next to each other? And with that one, we showed that if they got less than 6 hours of sleep that night, they showed no improvement the next day. If they got 8 hours, again, they tended to show 15 or 20% improvement. Improvement meaning that they could identify it reliably with an even shorter presentation time. Whereas if they had no sleep during the night, if it had taken them 80 milliseconds, if they had to see it for 80 milliseconds, they still had to see it for 80 milliseconds. So A, you have to have at least 6 hours of sleep. Until my graduate student, Sarah Mednick, came along and ruined everything because she wanted to study naps.
That's what I was going to ask.
And I tried to explain to her that we know you need more than 6 hours of sleep for this to get better. You know, a nap's not going to do anything. And she listened to me very politely and said, oh yeah, I see. And then snuck off and did the study anyhow. And it turned out that a 90-minute nap gives you as much improvement as an 8-hour night, while a 6-hour night gives you nothing. We still don't understand that at all. We really don't.
How about a 90-minute night?
Oh, Lord, we never tried that. How can you say, I love these podcasts. That's a brilliant idea. We don't know. You would think that would have to give you, I don't know. I suspect some of it has to do with getting the right kinds of sleep. So you asked about quantity of sleep and you talked about quality of sleep. So our sleep is not of a consistent form across the night. Lots of people know we have REM sleep or REM sleep, not named after the band, much as we wish it was. It's rapid eye movement sleep. And that tends to come in the later part of the night. Whereas deep sleep, what we call slow wave sleep, because the EEG has these large slow waves about this speed in the EEG, but tends to come more early in the night. And it turns out that to improve on this visual discrimination task, you need both slow wave sleep and REM sleep. And in an overnight environment, when you're getting a whole night of sleep, you need the slow wave sleep in the first part of the night and the REM sleep in the last part of the night. And it's actually multiplying those two amounts together that is this really, really strong predictor of how much you're going to improve. With a nap, you still need both, but the amounts don't seem to matter. If you get any slow wave sleep and any REM sleep during that 90-minute nap, you seem to show good improvement. And what this really does is it throws us back to asking the question, well, wait a minute. What's happening? What's happening to that memory during the night? And we have to say we don't know. And I usually fall back on and complain about other memory researchers and say, we don't know what happens to memories during the day. Right? I mean, I gave you that number 41324, and not only did your brain encode it, but it could find it again later when you went looking for it. And we don't know how it encodes it. We don't know what happened, if anything, between the time you encoded it and the time you recalled it. And we don't know how it recalled it. So when you push me just a little bit further and say, well, why would it only take 90 minutes in a daytime nap? And I would predict that 90 minutes at the start of the night wouldn't work because you wouldn't get REM sleep. But until we do the experiment, we don't know.
So the sort of sleep that you get in a nap, because of its diametrically opposite location in the circadian rhythm, you have a different sort of 90 minutes than you would have in the first 90 minutes of the night.
Right. It turns out, so I simplify when I say you get your deep sleep early in the night and your REM sleep late in the night. There's actually a 90-minute cycle all night long that goes non-REM, deep non-REM, up to REM, and then back to deep non-REM, and then back to REM, and then to not so deep non-REM, and then into much stronger REM. So you get a lot of people get a little bit of REM after just the first hour of sleep, usually just a couple of minutes. And the REM gets stronger in each of these 90-minute cycles, and that deep sleep gets weaker, and usually by the third cycle is completely gone. So in that first 90 minutes of a night of sleep, you get lots and lots of that deep, slow wave sleep, and almost no REM sleep. If we did this an hour after they woke up in the morning, they tend to get a lot of REM sleep and not much slow wave sleep. In the middle of the day, they're sort of at that balance point where they'll again have some of each. And we have no idea why mechanistically, and we have no idea why functionally.
Obviously, in a podcast, we can't be completely exhaustive about all the different sorts of memories and all the different nuances that go on here. But are there any other types of memories that sleep has a quite different effect on, or the story told about it is quite different from procedural memories?
No. It really feels like no matter what kind of memory we're looking at, whether it's just learning a list of words or typing a 5-digit sequence, or whether it's being given 200 trials of a probabilistic task where the stimuli sometimes predict one outcome and the same stimulus sometimes will predict a different outcome, but other stimuli predict those two outcomes with different probabilities. They get better at that overnight too, so that they have a better intuitive sense for any given stimulus, which one of the two outcomes is more likely. And what baffles me or fascinates me the most about all of this is that kind of across the board, we see a 10 to 20% improvement over a night of sleep. Nobody gets twice as good after a night of sleep. Nobody even gets 50% better after a night of sleep. And there's no examples where people are only getting 2 or 3% better. And as far as I can tell, there's no examples where sleep doesn't give some benefit. And that's maybe the most striking fact. We have all these different categories of memories that are stored in different parts of the brain and encode very different types of memory. I mean, if you try to imagine what the brain would do if it wants to remember the word pair tape, box. No, that's related. See, it's hard to come. Tape, chair, and what the brain has to do to get better at typing 41324. Those are very, you would think those memories are encoded very differently, and what the brain needs to do to stabilize them or enhance them over a night would be very different. And that might be why we have different stages of sleep. The strong hypothesis is that the different stages of sleep evolved to provide different physiological and neurochemical and electrophysiological environments that are tuned to optimally enhancing very different types of memories. So what you do for an episodic memory is flat out different from what you do for a procedural memory, and sleep had to evolve a totally different stage of sleep, if you will, to deal with that problem. But it seems to have dealt with them all. I don't know of any type of memory that isn't enhanced by sleep. We don't know any animals that don't sleep, and we haven't shown any animals that don't show sleep-dependent improvements in their memories.
Is it also I'm not so concerned with how much other animals need to sleep, but is it also a rule for humans that regardless of the sort of memory, to see the 10 to 20% across the board performance that you mentioned, it is either a 6-hour nighttime sleep interval or a 90-minute nap that will result in improvement?
Experiments haven't been done. I mean, I can show you a graph where on that visual discrimination task, where the amount of improvement that they have across the night is really strongly linear with how much sleep they got. And it hits the x-axis at 6 hours. So at 6 hours, they get zero improvement. And for every 5 minutes more than that, they show a little more improvement. I don't know if short sleepers don't need as much time. I don't know if long sleepers need more time, or if short sleepers don't get the benefit of those last 2 hours that are critical for learning that visual discrimination task, or if long sleepers are, quote, wasting the last couple of hours of their sleep because all the memory processing has occurred. Again, no one's done those studies yet. And they're really critical in some ways for understanding how this system works.